Hello everyone, this is Himabindu from the Department of CSIT. Today in this video, we would like to convert about the conversion of regular grammar to a finite automata. In the previous video, we discussed about the conversion between the finite automata to a regular grammar. So there is an equivalence between the conversion of regular grammar to a finite automata as well as finite automata to a regular grammar. So in this video, I would like to explain about the only conversion between the regular grammar to a finite automata. Let's move on to the slides. So here we already discussed the grammar contains 4 tuples and the finite automata which contains 5 tuples. We have to equalize those 2 tuples. So how to equalize those tuples we already discussed in the previous video, and again we are discussing right now with this. And here we are taking the finite automata. So we have finite automata which contains a 5 tuple. So which is Q is a finite set of states, and sigma which is the input symbol, and Q naught is the initial state, and F is the final state, and delta is nothing but it is a transition function. So here we have to equalize this to a grammar. So here we are converting the regular grammar to finite automata. So here we have a 4 tuple. So in that 4 tuple, V is equal to, so what is that? V is nothing but it is a non-terminal set. So it is represented with the capital symbol. So what are the non-terminals which are is equal to the finite set of states? So that suppose example Q0, Q1 and Q2. So these are the states of finite automata which is equal to Q. And next, what is the input? What is the tuple having a grammar? The T is equal to. So T is nothing but it is a non-terminal set. So terminal set which are represented with the small letters. So small letters here, what are the small letters? Are nothing but it is equal to the sigma. So which are contains the input symbols. So here, so we are equalizing this terminal with the input symbols. And next, initial state. So what is the initial state? And here which is equal to the start state. So that is S is equal to Q naught which is initial state. And next, so P are the productions. So P is a production which is equal to the transition functions. So transition functions for the finite automata, it's based on NFA or DFA or epsilon NFA. So transition functions are different from the different finite automata. So here in the transition functions, what are the states and inputs involved in that one? We are making with that productions. And here the transition functions, suppose Q0 comma A example. So Q0 comma A as an input, it is going to the next state is equal to the Q1. So this is the transition functions which are formed as a productions. How to convert this transition functions to the productions? In the sense, we have to take the production starts with S, and so here it is a combination of terminal and non-terminal. So suppose I am writing a non-terminal and with the terminal symbols, and there are 2 cases. So to form a productions, we have 2 cases. So terminal followed by non-terminal. So terminal T followed by non-terminal. And there is another case which are the productions having only terminal. So S tends to only terminal. So S will also represent this as a non-terminal. This is also non-terminal. S is equal to non-terminal. So in these 2 cases, how to convert these transition functions to the productions in the sense. So here the transition functions of this type, it involves, so it is of this type in when it is having the non-terminal and non-terminal. How to divide that into a transition function. So delta of non-terminal and with the input terminal, that is terminal, is tends to non-terminal. And when it is having the only terminal, in the sense it is like example S tends to A. So when it is only terminal it is having, it is reaching the final state. So reaches final state. So this already we discussed in the previous video. So S tends to only terminal, it is having the final state. So how to represent this transition function, in the sense the transition of S comma A. So we have to take a new state. When it is only having the terminal symbol, we have to take the new state and we have to name it as a SF. So it is a final state. Final state. So what is the new state here? SF, what we are taking whenever the single terminal is there in the right hand side. And this is also another. So how to form this terminal? So this kind of productions we have, how to convert that into a transition function, in the sense S comma terminal, what we are taking the terminal, giving to the next new state, what we are taking it as a new state. So in the production rules, we have the two cases. One is the terminal followed by the non-terminal, and only right hand side it is having the terminal. So how to form the two cases, how to convert the production rules into a finite automata transition functions. So these are the two steps we have to convert the regular grammar into a finite automata. And now we will explain more in detail about this conversion with the example. So here we have taken the example. It contains 3 production rules, and so let us write the tuple for this grammar. So grammar contains how many tuples? 4 tuples. So what are those 4 tuples? V, T and S, comma P. So here V is nothing but we have to equalize this with the finite automata tuple. So finite automata tuple which is having M, so which contains Q, sigma, delta and starting state. So starting state and final state. So here we have to equalize this one. So how to equalize, in the sense we have V is equal to, so here V is nothing but it is a set of non-terminals. So what are the non-terminals? Which is equal to Q, and so Q contains what are the non-terminals? So S, comma A, comma, what are the capital letters which are involved in this production rule? So here what are the capital letters? So A, B, A, B. So A, B, S, A, B. So these are the V, that is nothing but non-terminals. And next one is the terminals. So terminals which are having equal to the sigma, so which are equal to the sigma, and what are the input symbols involved in this production rule? See, 0, 1 and plus, minus, plus, comma, minus. So these are the terminals which are as an input symbols. And next starting state, S is equal to the start state. So S is nothing but here also representing the same. The production starts with S. So it is the S state. And P, production rules. How to write this production rules? In a sense, we have to elaborate these productions with this. So S tends to 0A and S tends to 1A and A tends to 0A and A tends to 1A and A tends to another input symbol plus B and A tends to minus B. And next one more production, B tends to 0B and B tends to 1B and B tends to 0 and B tends to 1. So these are the production rules which are involved in this grammar, and how to convert these production rules to a finite transition function. So in the previous slide we discussed we have two cases in the production rules. So when it is the right side, it is having the combination of terminal and non-terminal, we have to write the state name, and when it is only having the terminal symbol, we have to write the new state. And how to convert this into a transition function, see, and here we are taking the transition of, this is the present state, and this is the next state. So here the present state is S, and along with the input 0, it is reaching A. And transfer this one, a transition of S comma 1, it is reaching A. And transition of A comma 0, it is reaching A. And transition of A comma 1, it is reaching A. And transition of A comma plus, it is A comma plus, it is reaching B. And transition of A comma minus, it is reaching B. And transition of B comma 0 as an input, it is reaching B. And transition, here it is all the combinations of terminal and non-terminal. So terminal and non-terminal. So there is no single terminal in the right hand side. So here I am directly writing the only one transition function. So that is B comma 1 as an input, it is reaching B. And here we observe B tends to 0 and B tends to 1. So here we have to write the transition function B comma 0. It is reaching the final state. Let me write, this is the final state. We have created C is equal to, here C is the final state. That is the new state which is not there in the production rules. So here, and B tends to B comma 1 as an input symbol, it is reaching C. And here this production with this transition functions, we will form a transition diagram with these functions. So here with all the inputs. So here what are the states we require for this one? So S, it is a starting state, and A, B, and new state is C. So new finite is reaching, whenever it is having single terminal, we will represent it as a final state, and that final state is represented with the double circle. And for this S tends to 0, it is reaching, S tends to 0 comma 1, it is reaching A. And A tends to 0, 0 comma 1, it is reaching itself, so 0 comma 1. And A tends to plus and minus, it is reaching plus comma minus, it is reaching B. And B tends to 0 comma 1, it is reaching itself, so B 0 comma 1. And B tends to 0 and comma 1, it is reaching the final state 0 comma 1. So this is how we converted this production rules to regular grammar to finite automata. So here we converted this example. We have given in production rules. So this belongs to the regular grammar. So regular grammar is converted to a finite automata. And next example. So here we have to discuss along with the production which are having a null symbol. So here how to convert this null symbols production rules to null free production rules. So here there is a logic. So here for how we can say it is having the null. So here whenever the right side, the production rules right side having the null values, it is represented as a epsilon regular grammar. So a regular grammar which contains the null symbol. So first of all, what step we have to do, in the sense we have to remove this epsilon symbol. So how to remove and how to free this production rules with the epsilon free grammar. So how to free, in the sense we have to write the states. Whenever we are having the right side, we are having the epsilon symbol, we have to write that to a states without epsilon. So how to write this? S tends to A, we have to substitute this one. So we will elaborate this A, B, B, and we are just removing for now, and we will add A tends to AS, and next B tends to CS, and epsilon we are not including. So this is the epsilon free, and here epsilon, whenever we have the symbol S tends to epsilon and B tends to epsilon, we have to append this values. So append this production rules. So how to append this production rules? In the sense, whenever there is an occur of S tends to epsilon, we have to substitute this S with the epsilon, and what is the output we will get, that output we will be appended to that production rule. So here whenever we are having the epsilon, so here we are not, B tends to epsilon is there, and here whenever the production rules which is having a B, it is replaced with the epsilon, and B is epsilon and it is having output B. So that output is appended to that production rules, and like that S tends to epsilon is also there, and for this B comma S, so that is epsilon when it is output A. So A is appended to the production rules, and same whenever there is B tends to CS is there. So C epsilon, so it is C as in terminal. So we have to represent with the small letters. So C tends to C epsilon, it is the output C, and this is appended to the production rules. So this is how we given the appended output results to the production rules. And one more thing, whenever we are having the start state now epsilon symbol, we have to add the one more new state. So how to add that one more new state? In the sense, so S1 we are adding, so S1 and epsilon along with the epsilon symbol. So here the right hand side, whenever it is having the S symbol, we have to add the one more state S1. So S1, we have to write, how to write the S1. So this is the thing what we have to write as an S1. S1 is equal to A, B, B, and along with the B, we have to add the epsilon symbol. So we have to add the S1 epsilon symbol, and we have to write this S1 as a final state. So whenever we are having the epsilon symbol in the production right hand side of the production, so that non-terminal is a final state. So here what are the final states? Here S1 is the final state, and here there is a terminal, only terminal symbols are there. So what we have to do? We have to add the new state, that is a final state. So how to add that new state? Here what are the Q contains, or Q or equal to V contains the states S, capital letters A, B, A, S, S. So what are the S, A, B, and we are adding the one more state, new state, so that is represented with the capital C along with the S1, what is the new state when it is having the epsilon symbol in the production. So whenever we have the production symbol right hand side having the epsilon, we have to add the state, another state, and whenever we are in that production, if we have that only terminal symbols, we have to represent a final state also. So with this, we have the two final states. So what are the two final states? In the sense, C comma S1. So we have to write this C comma S1. So what are the states? How many states we have? 5 states. So let me write, we will write C, capital C in the middle, and we will write B and C. Sorry, S. So S is also a final state, and we already have the Q, that is V is equal to what are the states, how many terminal, non-terminal states are there, and next we have to write the epsilon symbol. So epsilon is nothing but it is having the A, B, only A, B, C, and C is also A, B, C. And next, what is the start state here? The start state is S1. So why? Because we are adding the new state. So that is whenever we are having only the start state only contains the epsilon symbol. No other state should not contain the epsilon symbol. So start state is S1. So S1 is the start state. And next one, what we require for the finite automata is Q, epsilon, S, and final state, or final states are two states. So what are those two states? C, S1. And the production rules that are equal to the transition function. So here transition functions is equal to production. So here I'll write the production rules. So what are the production rules are there? So S tends to A. So that is represented as A. So let me write here. So that is represented as transition of S, A, which is equal to a final state, that is C. So why? Because only terminal is there, that is reaching the final state. And next one is tends to, here we have to write this one. So here first step is not with the start state, we have to start with the S1. So these are the appended. So after free from the epsilon, the productions epsilon free, we have a new states, we have to start with the new state. So transition of S1, A, it is reaching the final state C. And we are directly writing the transition of S1, A, it is reaching the another state A also, and transition of S, B, it is reaching the state B, and transition of S, B, it is reaching the, so only terminal is there, so B terminal is there, it is reaching the C. So we will represent this, and epsilon also. So epsilon is nothing but we are including with the start symbol. And here let me write this 4, and S tends to A, S1, so all are this S1. So S1 tends to A, it is reaching the C. So S1 tends to A, it is reaching the C, and S1 tends to B, it is reaching the C. So let me write A, B is from the S1. When we are giving the A, B input, it is reaching the final state. And again, from here, A tends to, whenever we give A as an input, it is reaching the final state from the S1. And whenever we are giving the B as an input symbol, it is reaching the B state. So these are the 4 production rules. So 4 production rules which are converted to the transition function. And next production rule, what we have to take, S1 is completed, and S we have to take. So transition of S, A, it is reaching the final state C. So why? Because only one terminal is there. So transition of next S, A, it is reaching the state A, and transition of S, B as an input, it is reaching the B, and transition of S, B as an input, it is reaching the final state. Why? Because only a single terminal is there. So what are the final state reaching? A with the input symbol from the state AS, it is having the input symbol A, B, it is reaching the final state. So here also. And what are the other 2 transition functions from the state AS? So whenever it is having the A input symbol, it is reaching the state A. and whenever it is having the B input symbol, it is reaching the state B. And we finished S1 and S, and we have to take care of these two production rules, and we have to convert the two production rules into a transition function. So transition of A comma A, which is belongs to the state A, and transition of A comma input symbol A, it is reaching the S, and along with that A tends to A, it is reaching the final state, that is C. So here I will write this transition of A comma A. So from A state to we have to take the all input symbol. So from A state to A, it is reaching the final S. So it is also reaching the self state, and whenever we give A as an input, it is reaching the final state A. And we finish this production rule, and we have to finish this transition of B comma C as an input, it is reaching this S state. So transition of B comma small input C, small letter C, it is reaching the final state capital C. So from B state, whenever we give C as an input, it is reaching the state S, and whenever from the state B, whenever we are giving the C as an input, it is reaching the final state C. So this is how we converted this regular grammar to a finite automata. So here whenever the regular grammar which contains the epsilon symbol in the right hand side, first step what we have to do, we have to remove that epsilon symbol in the start state, and again we have to add the newmost state to that one, that is represented as S1, and we have to append whenever we have the terminal symbol which is equal to the epsilon, we have to append that output to the production rules. So this is how we converted the epsilon symbol grammar is converted to the finite automata. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.